This is LeetCode problem 36, valid Sudoku. Determine if a 9 × 9 Sudoku board is valid according to the following rules. Each row must contain digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of 9 3 × 3 subboxes of the grid must contain digits 1 to 9 without repetition. So basically our goal is to check if there is any duplicate numbers in every row, every column, and each of 3 × 3 subgrids. Checking for duplicates, hash set will be a very good technique. We iterate through the number, then store them in a hash set. When we encounter a new number, we can check if it's already in the set. If it is, then it's a duplicate. In this problem, we basically need to break it down to 3 parts: rows, columns, and subgrids. For the first part, rows, we can have a hash set for each of 9 rows and keep track of duplicates in each row separately. We create an array of 9 hash sets for each row. Each row has an index. We can access a row's hash set by its index. And the same for the columns. The challenging part is for subgrids. If we visualize subgrids, we can see them displayed in a 3 × 3 grid. Then how do we index each of these subgrids? We can basically convert those indexes ranging from 0 to 8 to adjusted indexes from 0 to 2, as we shown in the picture here. In order to get the new subgrid row and column indexes, we can divide the original indexes by 3 using integer division. 0, 1, 2 divided by 3, that will be 0. 3, 4, 5 divided by 3, that will be 1. 6, 7, 8 divided by 3, that will be 2. And then from there, we can access hash set of a subgrid by using adjusted indexes. Subgrid sets row divided by 3, column divided by 3. In summary, we first initiate hash sets, 9 for each row, 9 for each column, 9 for each subgrid. As we iterate through each cell in grid, we check if a previously encountered number already exists in current row, column, or subgrid. If a number is in any of these hash sets, then we return false. It means we encounter duplicates. Otherwise, add it to corresponding row, column, and subgrid hash sets. If we successfully iterate through board without encountering any duplicates, then it indicates Sudoku board is valid. Therefore, we can return true. This is the coding part, exactly the same as what we said in our summary. One thing to call out is, if the current cell is an empty cell, then we use if cur equal to dot to represent it. We just need to continue the code. Time complexity is O of n squared. Space complexity is O of n squared as well.